Okay, good morning. Today we are going to see 12th chemistry chapter. We are going to see biomolecules. Into that biomolecules, today I am going to take about denaturation of proteins. Okay. So first, what is proteins are made up of? Generally, you can take proteins as a three-dimensional structure. Okay, proteins what are three-dimensional structure. Okay, and this three-dimensional structure can be made up of. Okay, those made up of first one, disulfide bond. Okay, it can be made with the hydrogen bond, or this can be made with the hydrophobic bond. Or it can be made with the electrostatic bond. Okay, so made up of three-dimensional structure, and those structure consist of a disulfide bond, hydrogen bond, hydrophobic bond, and electrostatic bond. Okay. And what is called denaturation means the disturbance made on these three-dimensional structures only, we can name it as a denaturation. Okay, so how did you bring the denaturation of proteins? Okay, so this denaturation of proteins brought by. So what are all the factors we can use to denaturate the proteins? Okay, so if you are taking proteins while you are exposing to high temperature, okay, so exposed to high temperature, on exposure to high temperature, okay, or by using chemicals. You can use chemicals such as urea. By using of chemicals we can denaturate, or while you are altering the pH, value, okay, or by considering the ionic strength. So just the proteins can be denatured by just if you are taking a protein, when it is exposed to high temperature you can denaturate. By using of chemicals, if you add urea you can denaturate. If you altering the pH value of a protein you can denaturate, or by using of a ionic strength you can denaturate the proteins. Okay, so while you are denaturating the proteins, we know that proteins primary, secondary, tertiary, quaternary structures are available. So while you are denaturing the proteins, only the primary structure is intact, that is by denaturing the proteins, okay, there can be loss in structure, but but primary structure is intact, that is not altering. Intact, that should be restored. Okay, and because of that intact nature of the primary structure, okay, the reversal of the reactions can be occurred in certain proteins. That is, because of the intact nature, the reversal of proteins occurs in certain proteins only. This type of reactions can be possible. But this reversal can be brought about by two conditions. So how did you bring about the reversal nature? By using of the two conditions. By restoring the original condition. By restoring the original condition, one thing, or by using a enzyme. So the enzyme, the name is by using of an enzyme safranes. Okay, safranes. By using of an enzyme safranes, you can bring about the reversal of a protein. So anyway, we are losing the structure, but the primary structure is intact. So how did you give the definition to the denaturation? That is, the denaturation is nothing but, okay, the process of losing higher order structure, okay, without the loss of primary structure. Without the loss of the primary structure. Anyway, in denaturation, while you are using that process, the primary structure can be remain as it is. So the process of losing higher order structure without the loss of primary structures only, definition for the denaturation of a protein. Okay, and while you denaturate the protein, its biological functions also can be lost. So during this process, the biological function of a protein can also lost. Proteins also lost. Okay. For example, so if you are taking that, for example, you can take the coagulation of a egg. That is, coagulation of a white part of a egg. Okay, white part of egg by heating. This is a good example for the protein denaturation. Okay, so just we are given what is denaturation of proteins means. Just we are given the structure, how the protein structure is made up of. How can you denaturate the proteins? By using of various process. And what is called denaturation definition I have given, and what is the example. Just I have mentioned the coagulation of a white part of the egg by heating. Okay, next we are going to see the importance of proteins. Okay, all biochemical reactions, that is biochemical reactions carried out by using of a catalytic protein. Okay, catalytic protein called enzymes. Called as what? Enzymes. So usually the biochemical reaction that should be catalyzed by using of a catalytic proteins. The catalytic proteins only named as a enzyme. Okay. And next, if you are taking keratin, this is one protein. Okay. And choline, that is also one of the protein. It will be act as a structural backbones. Structural backbones. Okay. And same way, if you are taking the antibodies, usually what happen, antibodies that helps the body to fight against various diseases, to fight against various diseases, that helps the protein functions. And same way, proteins are also act as for transporting molecules. Okay, to transport molecules. Okay, and same way, organelles in cells. Okay, and to function, that is, if you want to put, that is inside and outside of the cell, the molecule allowance inside and outside of the cell to pass the molecules, we can use the purpose. Okay, and same way, proteins act as messengers to coordinate many functions. For example, I will give you one action, that is, if you take the enzyme, namely glucogen, okay, and insulin, these two enzymes helps to measure the glucose level in the blood, helps to measure glucose level in blood. Okay, and same way, if you take this proteins, it helps to store the metals, helps to store metals. Example for this, iron we can take. So iron is a metal. If you want to store iron metal, that will be carried out only by using of a protein. Okay, and in the similar way, protein acts as a receptor. Act as receptor. Okay, to activate, to bring, okay, signal molecules, to bring signal molecules and activate the functions. Okay, that will act as a receptor to brings about the signal of the molecule, and by absorption of those signals, it will activate the function by using of signals. Okay, so those, they are given as the importance of proteins. So one will be used as a catalytic, the process called the enzymes, and 2 enzymes that will be used as a backbones, and antibodies, what is the function of antibodies they are given, and to transport molecules, organelles in the cell, and inside and the outside flow of the molecule, that will be controlled. And protein act as a messengers to coordinate many cell functions. They are given insulin and glucogen. It is used to measure the glucose level in the blood, and sometimes that will proteins that will help us to store metals like iron and act as a receptor. Okay, so this is the importance of proteins. Next we can move with the enzymes. So what is called, first of all, enzymes? Enzymes are a biocatalyst. This can carry out many biological processes. These enzymes are called as biocatalyst, and this can bring out many biological processes in the living cell. Process in the living cell. Okay, what are all the biological process? So I will give you the biological process as, first one we will take generally digestion of a food. This is one of the biological process. Okay, and same way synthesis of a necessary molecule. Synthesis of a necessary molecule for the molecular function, for the molecular functions. These are the 2 examples just I have given for the biological process. Okay, and this can be brings out only by using of a special catalyst that is called the enzyme biocatalyst. Okay, and this biocatalyst helps to increase the rate of the reaction. So how many times increase means 10 power 5 times that rate of the reaction will be increased. Reaction will be increased. Okay, next the question will comes. How did you increase the rate of the reaction? Generally, the rate of the reaction can be increased. Okay, can be increased by reducing the activation energy. By reducing the activation energy. Okay, how did you reduce the activation energy means by stabilizing the transition state, that is intermediate state. Okay, generally if you have used enzyme act as a catalyst, and because of that usage the rate of the reaction can be increased 10 power 5 times. Okay, 10 power 5 times the rate of the reaction will be increased. Okay, how did you increase the rate of the reaction means by reducing the activation energy. So reducing of activation energy can be done by the stabilizing the transition state. Okay, next I will give you examples of the enzyme catalyst reaction. Okay, so here I am going to take example enzymes catalyst reaction. If I am taking an example carbonic anhydrase, this is an enzyme that is used for the interconversion of that is carbonic anhydrase. This is an enzyme used for interconversion of carbonic acid to carbon dioxide and water. So the enzyme carbonic anhydrase that should be used for the interconversion of a carbonic acid to carbon dioxide and water. Okay. And second, sucrase. This enzyme, it is used for the hydrolysis of lactose into glucose and galactose. You know, glucose and galactose, both are having the same formula, C6H12O6. Sucrase is an enzyme that brings about the hydrolysis of a lactose to glucose and galactose. These two examples for the enzyme catalyst reaction. Okay. And next we can see the mechanism of a enzyme. Mechanism of a enzyme reaction. Okay. So here many biological reactions are carried out by using of a enzyme. We know already. And this enzyme should be catalyze only specific reactions. Okay, enzyme catalyst only specific reaction. Okay, and we know that because of this the catalyst should have a high specificity. Okay, this catalyst having what? A high specificity, okay, and because of this high specificity in nature, it allows a reaction to occur within the cell. Because of that high specificity, because of this nature, this allows the reactions to occur within the cell. Because of that high specificity of a catalyst, it helps us the reactions that should be taken or that should be occur only within the cell. It is not coming out. Okay. Next we will see what is the mechanism involved in the enzymes. So usually enzyme, it is going to catalyze one reaction. Okay. Suppose if I am taking the enzyme as E. Okay. Enzyme as a E. And next, if the enzyme should be catalyst, no, that I should take one substrate. The substrate as S. So whenever the enzyme approaches the substrate S, it forms a complex, that is enzyme substrate complex. It is a complex name is enzyme substrate complex. Okay, so whenever the enzyme approaches the substrate, it forms a complex enzyme substrate complex. Okay. Next, after that reaction over, the enzyme substrate complex, okay, in that the substrate will be considered as a product. The substrate will be converted into product, and the enzyme will comes out. That should be a catalyst, and because of that the enzyme will be comes out from the reaction, and this enzyme will catalyze another reaction by taking another substrate. So the enzyme will going on, will further reactions will be carried out by the enzyme. So but the substrate only converted into product. Okay, so whenever the enzyme approaching the substrate, it forms an enzyme substrate complex, and next the enzyme substrate complex will be what converted, that should be converted, that should be what given out, so where the substrate only converted into product, and the enzyme is regenerated. The regenerated enzyme will be acting as a catalyst for another reaction, so that reactions will be carried out. Okay, so this is enzymatic mechanism reaction. So here they are given that lock and key model. This enzymatic, the enzyme and substrate combination, they are given that name of the process is lock and key model. Okay, and next we can see about what fats. So we know that fats, okay, if you take fats, so fats are an organic molecule. So generally this is an organic molecules. Okay, so whether this is dissolving in an organic solvent or an inorganic solvent, like that, if you are taking that, generally the fats are soluble in organic solvent. Organic solvent. Usually the solvent we can use chloroform and methanol. Usually we can use a solvent chloroform and methanol, that will be used as an organic solvent. So the fats are soluble only in the organic solvent and insoluble in water. The fats are insoluble in water. And if you take this fats, that gives us that is giving energy. Okay, so this can be used as a saving of energy, that is energy saver. So to serve energy or to save energy, we can take this. To save energy, we can take fats. Okay, so fats are energy saver. Okay, and next this here, if I am taking this fats or the Greek word. Okay, so the fats obtained from the Greek word lipos. Lipos. Okay, fats are obtained from the Greek word lipos. The meaning is fat. You know that meaning is fat. Okay, that is the fat is actually obtained from the Greek word lipos. The meaning for this is fats. Okay, and this fat actually 2 to 3 folds. Okay, 2 to 3 folds having higher energy. That is, if you are comparing higher energy compared with the carbohydrates and proteins. Okay, so if you are comparing the energy, the fats energy is 2 to 3 folds higher compared with the carbohydrates and proteins. Okay, so fats means what is organic molecule that should be soluble in organic solvent, insoluble in water. So it should be act as an energy saver, and obtained from the Greek word lipos, meaning for this is fat. And what about the energy? This is 2 to 3 times higher compared with the carbohydrates and proteins. Okay, next we are going to discuss about classification of lipids. Okay, so next the classification of lipids based on the structure. Okay, so based on the structure only we are going to classify that is lipids. Okay, so usually the lipids has 3 types of classification. Okay, so one is simple lipids. Okay, one is simple lipids, and second one is compound lipids, and derived lipids. Okay, so there are three types of lipids. One is simple, second one is compound, and third one is a derived lipids. So in the simple lipids, again we are going to divide into two types. One is fats and second one is a waxes. Okay, so what are fats means? These fats are, okay, esters of higher fatty acids. That is, fatty acids are long chain fatty acids, higher fatty acids, long chain, okay, with the glycerol, okay, with the glycerol. So esters of long chain higher fatty acids with the glycerol considered as a fats. And what is called a waxes means, this waxes also esters of fatty acids with the long chain monohydric alcohol. Long chain monohydric alcohol. Okay. And simple means just we are divided into fats and waxes, and those contains with glycerol and monohydric alcohol. Next take a compound. So here compound also, it is a esters of a simple acids, that is compound, esters of simple acids with glycerol. Okay, but in compound, in addition to that, we are having some groups, that is side groups attached. So based on that groups, again that compound lipids, okay, again classified into three types. This compound lipids, okay, classified into three types. Okay, and one is, if you take phospholipids, one is phospholipids, and second one is glycolipids. Okay, phospholipids, second one is glycolipids, and third one is lipoproteins. Okay, there are three types. And phospholipids contains phosphoester linkage. Phospholipids contains a phosphoester linkage, and glycolipids contains sugar molecule, whereas lipoproteins contain complex of lipids and proteins, those molecules involved in the compound lipids. So compound lipid has three types, okay, and examples. Whereas if you take derived lipids, the derived lipids we are going to get from simple and the compound. Okay, but how did you get that? By the hydrolysis. So hydrolysis of simple and compound lipids. Okay, we are going to get derived lipids. Okay, so hydrolysis of a simple and a compound lipids, and those derived lipids also contains fatty acids, glycerol. Okay, and in addition to that, signophore compound, and signophore in addition to that steroid derivatives also. Steroid derivative. The signophil is actually carbon 18 compound. So C18H37NO2, that is carbon 18 compound containing amino alcohol, that is carbon 18 containing amino alcohols. Okay, So just we have taken the classification of lipids based on the structure. We are divided into three: simple, compound and derived. Simple is made up of fats and waxes, and those contains esters of fatty acids with glycerol, one thing. Waxes contain esters of fatty acids with long chain monohydric alcohol. Here long chain fatty acids, here long chain monohydric alcohol. And compound containing esters of simple fatty acids with glycerol, and those based on the side group, just we are dividing into three: phosphoglycolipids and lipoproteins, and the examples given. Same way, derived proteins means how did you get a derived proteins? Hydrolysis of a simple and compound lipids, we are going to get a derived proteins, and that should contain same manner fatty acids, glycerol and signophil, steroid derivatives, and the signophil compound C18H37NO2, that is generally a carbon 18 compound. Okay, and next we are going to see about the characteristic of a lipids. Characteristic of a lipids. Usually lipids act as an integral component in the cell membrane. Okay, so first that should be acting as an integral component in cell membrane. That should, second thing, that should be acting as a protective, okay, coating. So where it gives protective coating means to the internal organs. So that should be act as a protective coat in internal organs. Internal organs. Okay, and the same way that that gives more energy. So if you are comparing carbohydrate and protein, it gives more energy compared with carbohydrate and protein. Okay. And the same way it should act as a productase in aquatic organism. Act as productase in aquatic organism. Okay. And if you are taking that for the absorption and the transformation, that is absorption and transformation of fat soluble vitamin. Fat soluble vitamins. Okay, just we can take a lipids. By using of lipids only we will do all the transformation. Okay, and for the that is emulsifier. To just it will be acting as a emulsifier. Okay, for fat metabolism. Fat metabolism. Okay, and same way for the stimulation and the growth, that is for stimulation and growth, that is growth of enzymes, namely the enzymes, lipase. We can use this lipids. Okay, so characteristic of lipids means that is used as a integral component, usually cell membrane, that acting as a protective coat in internal organs to protect the internal organs. And comparing energy, those energies are 2 to 3 folds higher compared to the carbohydrate and proteins. We know that lipids has a energy save. Okay, and act as a productase in aquatic organism for the absorption and the transformation of a fat soluble vitamins also we can take, to emulsifier for fat metabolism, for the stimulation and the growth of a enzyme lipase we will take a lipids. Okay, and today just we are taking consideration about biomolecule chapter. We are discussing about enzymes. Okay, so enzymes and lipids only. Okay, thank you.